Pre-statistics. Using elimination to solve systems, Part 4. Lesson objective: solve word problems involving systems. Lesson objective: 4 steps to solve word problems involving 2 variables. Step number 1, understand the problem. Step number 2, devise a plan. Step number 3, carry out the plan. Step number 4, look back. So for step 1, understanding the problem, this is where we're going to assign the variables. So the first step is to understand the problem. What are you trying to solve? What is the question asking for? In many cases, it's very important to identify what's the independent and the dependent variables. Thus, you will want to assign the variables. If there are 2 quantities to solve for, you will need 2 equations involving these variables. Step number 2, devise a plan, and that means we're going to translate into equations. So we want to set up an equation, we may want to draw a diagram or make a chart, and that will help us go about solving the problem. Another thing, we want to look for words that will translate into mathematical operations and or variables to form the equations. And normally this is the hardest part of a word problem. Step number 3, carry out the plan, and that means we're going to solve the equations. So we want to solve the system of linear equations using one of the 3 methods that we discussed, and that's graphing, substitution, or elimination. Most of the time the layout of the equations will determine which method will be the easiest to use. Step number 4, look back. We want to check and interpret our solution. So you want to ask yourself, does the answer seem reasonable in the terms of the problem? Verify the answer by checking the solution in each equation to see if it produces a true statement. If the answer checks, be sure to answer the question in terms of the problem. Let's do an example. Example 8. One car model costs $12,000 and costs an average of 10 cents per mile to maintain. Another car costs $14,000 and costs an average of 8 cents per mile to maintain. If one of each model is driven the same number of miles, after how many miles would the total cost of one model be the same as the other? So we have 2 variables here, cost and a number of miles. So the question is asking how many miles would the cost be the same. This is going to help us set up the 2 equations. So we have 2 models. We're going to have 2 equations involving number of miles and cost. So the independent variable is the number of miles because the total cost depends upon the number of miles. We'll define N to be the number of miles and C to be the cost measured in dollars. So for the first model, we have C equals 12,000 plus 0.10 times N, the number of miles. And for the second model, we have 14,000 plus 0.08 times N. So we are done with step 2. Step 3, we want to solve this system. Now we could graph it. We could also use substitution. I'm going to solve this by elimination. So I'm going to take the second model and multiply it by -1. This way my C term here will be -1C, and we have a positive 1C here, and the C's will cancel. So adding the equations, we get 0 equals -2,000 plus 0.02 N. Adding 2,000 to both sides, we have 2,000 equals 0.02 N. Now we divide by 0.02, and we see that N is 100,000. So in the terms of the problem, we would say the number of miles traveled is 100,000 for both models to be the same cost. If you plan to drive 150,000 miles, which model would you pick? How much would you save? So in this case, we are given N and we want to compute C. So for the second model, we have 14,000 plus 0.08 times 150,000, which is 26,000. And for the first model, we have 12,000 plus 0.10 times 150,000, and we end up with 27,000. So the model with the 8 cents per mile to maintain would save you $1,000. Example 9. A hot air balloon is 10 meters above the ground, rising at a rate of 15 meters per minute. Another balloon is 150 meters above the ground, descending at a rate of 20 meters per minute. After how long will the balloons be at the same height? What is the height? So again, in this case, we can identify the variables by the question. We want to find out how long, so we want to find out time, and we want to find out height. And it also helps to see here, we can think of this as slope, 15 meters per minute. Per means to divide, so this is the change in y over the change in x. So for every minute increase, the height is increasing 15 meters. And for the second balloon, descending means it is dropping, so the slope's going to be negative, and that's 20 meters per minute. So every 1 minute increase, the height will drop 20 meters. So the independent variable is time, and that's measured in minutes, and the dependent variable is height, measured in meters. We'll let n equal the number of minutes and h equal the height. So for the first balloon, h equals 10 plus 15n, and for the second balloon we have h equals 150 minus 20 times n. Step 3, we want to solve this system. In this case, we could use elimination. I'm going to solve this system by substitution. So basically, I'm taking this expression and setting it equal to this expression. So we have 150 minus 20n equals 10 plus 15n. We have n's on both sides, so I'm going to add 20n to both sides. So we're left with 150 equals 10 plus 35n. Subtract 10 from both sides and divide by 35. We see that n is 4. To find the height, we pick one of the equations. I'm going to use the first one. We substitute n4 for n, and we see that the height is 70. So in 4 minutes, the two balloons will have the same height, and that height will be 70 meters. Example 10. The beach resort is offering 2 weekend specials. One includes a 2-night stay with 3 meals and costs $195. The other includes a 3-night stay with 5 meals and costs $300. What is the cost of a 1-night stay? What is the cost per meal? What is the cost for a 1-night stay, and what is the cost for 1 meal? That is our two variables. So we're going to let S equal the cost of 1-night stay, and M is the cost of 1 meal. So using the information given in the problem, 2 nights plus 3 meals equals $195, and the other special was 3-night stay plus 5 meals equals $300. So we have our system. So step number 3 to solve this system, it looks like elimination is going to be the easiest to use. So I'm going to eliminate the s's. So we need to multiply this equation and this equation by two numbers where when we add the two equations up, we will get 0. So I'm going to multiply the first equation by 3, and that will make this first term 6s. Therefore, I need to multiply the second equation by a -2 to make it -6s. So using the distributive property for every single term in the equation, we have, for the first equation, 6s plus 9m equals 585. And for the second equation, we have -6s minus 10m equals -600. Adding these two equations, the s's cancel. 9m plus -10m is a -1m, and that equals -15. Dividing by -1, we see m is equal to 15. To find the value of s, we take one of the equations, and everywhere we see an m, we stick a 15. So in this case, we have 6s plus 9 times 15, that equals 585. 9 times 15 is 135. Subtract 135 to both sides of the equal sign, and divide by 6, we see that s is 75. So what does this mean in the terms of the problem? The cost of a one-night stay is $75 and the cost per meal is $15. Our last example, Mr. Horn tells you that next week's test is worth 100 points and contains 29 problems. Each problem is worth either 5 points or 2 points. Because you are studying systems of equations, Mr. Horn says that you should be able to figure out how many problems of each are on the test. How many of each value are there? So x is the number of 2-point problems, y is the number of 5-point problems. Our next step is to write our equations involving x and y. The first equation is the number of problems, which is a total of 29. The second equation is the number of points, which total 100. So our first equation is going to be x plus y equals 29, the number of problems. The next equation will be 2 times x, because x is the number of 2-point problems. Y is the number of 5-point problems, and we know that when these two are added, we have 100 points total. Our next step is to solve this system. Now I'm going to solve this system by substitution. I'm going to take the first equation and solve for y. So I subtracted x to both sides. My next step is to take that expression negative x plus 29 and substitute it in to the second equation. So we have 2x plus 5 times the quantity negative x plus 29. Using the distributive property, we have 2x minus 5x plus 145 equals 100. Combine like terms, we get negative 3x plus 145 equals 100. Subtract 45 to both sides and divide by negative 3. We have x is 15. To find the value of y, we substitute 15 in for one of the equations. In this case, we have negative 1 times 15 plus 29, and that gives us a value of 14. So answering the question in terms of the problem, we would say there are 14 5-point problems, and that was y, and there are 15 2-point problems, and that was x. So we want to be sure that when we answer the question, we put it back in terms of the problem. We don't want to just leave them x and y. Thanks for watching.